Good afternoon, everyone. My name is Peter Menzies. I'm a geospatial analyst and developer at the McClintock Lab based at the University of California, Santa Barbara. And I'm going to be talking about SeaSketch, which is a marine spatial planning tool that our lab develops, and how it's of value to IEA stakeholders. Okay, so first a brief outline. I'll start by giving you the 10,000 meter view of what SeaSketch is. Then we'll briefly talk about why SeaSketch was created in the first place. I think it gives it some important foundational context. Then we'll talk more specifically about what SeaSketch is capable of. This is not a talk about the underlying software, as much as I'd love to talk about it. So I'll keep it high level, but I will outline its functionality in some detail. And lastly, I'll discuss how SeaSketch was used in the Mission Atlantic case study in the South Brazilian Shelf, and how it's continuing to be used there, and how it is used in the Azores and a few other places. Okay, so what is SeaSketch? Most simply, it's a web-based platform built on leading-edge technology that supports marine spatial planning. It allows stakeholders to actively participate in the planning process. It's designed specifically to be intuitive and easy to use, and it's totally free and open source, and that's no strings attached. This is not a commercial pursuit. The code base is publicly available online, and we encourage everyone to create their own project after this. Okay, so a little bit of background, just a quick history. How did SeaSketch come to exist in the first place? In 1999, California passed the Marine Life Protection Act, and this essentially directed the state to redesign California's set of hodgepodge marine protected areas into a network in order for them to work more cohesively. Between 1999 and 2003, experts designed plans in an opaque fashion. They then brought those plans to the public for feedback, and it didn't go well. The plans were nearly universally hated. Fishers didn't like them. Conservationists didn't like them. Nobody liked them. So unsurprisingly, no new MPAs were created. Between 2004 and 2011, the state changed course and instead decided to maximize stakeholder involvement. And when stakeholders were provided the right tools to express their values, interests, and ideas for where the MPAs should go, we ended up with a cohesive network of 124 MPAs signed into law. A key component of the success was a web mapping tool developed by our lab called Marine Map, and it allowed non-technical users to draw and assess the impacts of protected areas. Prior to this technology, any proposed plans would have to be handed off to GIS experts who would conduct analyses, and that might take hours or even days, and then bring the report back to the public. With Marine Map, stakeholders representing the interests of fishers, divers, conservationists could attend workshops where they simply drew their ideas for a plan on a web map, and then they could get near instant results of how that impacted things like human ocean use or conservation targets. Marine Map evolved into the modern day SeaSketch. Same idea, just slightly catchier name and a lot more powerful. And SeaSketch is now used in projects all around the world for MSP, research, and much more. Okay, so how does SeaSketch actually help facilitate these things? And I think facilitate is an important word. Our lab, this software, we're not trying to perform MSP. We're just trying to provide the tools to help make it more stakeholder driven. So as an overview, SeaSketch can essentially be broken down into three components. It's a data portal, it's a survey tool, and it's a planning tool. And we'll dive into each one of those. So for a lot of projects, SeaSketch is a data portal, which just means a single repository for spatial data that's accessible anywhere via the internet. Users can upload, view, style, and download data. And this includes vectors and rasters of many formats. And you can even connect to map services like Esri Web Maps. Data sets have descriptions, so it's possible to add metadata to all of them, which is always encouraged. Users can interact with the data sets on the map. So for example, you could click on the feature of a particular vector layer, and you could get a pop-up saying something about that feature. Data can also be updated with old versions being saved, or version control, along with a changelog, so that there's a recorded history of how data has changed over time. CSketch is also a survey tool, so it offers an easy way to build and implement participatory mapping surveys. So in other words, surveys that collect spatial information from the public without the need for the respondents to have any technical expertise, and with the survey facilitators requiring minimal training. So how has this feature been used in practice? CSketch surveys have been used to understand human ocean use through ocean use surveys, and we'll look at some real-world examples of those a bit later. They've been used to capture traditional knowledge that may otherwise be left out of impactful analyses. For example, we recently worked with the Micronesian government to collect data on spawning aggregation areas, and that was previously totally unknown. CSketch surveys have even been used to map impacts of disasters. Last year, there was a shipwreck off the coast of Samoa, and we worked with the Wade Institute and the Samoan government to build a survey that essentially allowed them to crowdsource information on how the shipwreck was impacting the environment to inform their response to the incident. And the survey tool is easy to use, both for the respondent taking the survey and also building a survey is an entirely graphical interface. Requires just like a little bit of training, and anyone who can use a computer can build a survey. Okay, the third function, CSketch is also a planning tool. So with this, users can draw areas on a web map and get instant feedback on, for example, how protecting those areas would help to meet conservation goals or how it would impact forms of human use. As previously mentioned, these types of analyses would require GIS knowledge and time. And now anyone with a computer and internet access can do these same analyses typically in seconds. These analytics are fully customizable to fit a project's specific needs. So essentially, they're designed to answer the most important questions for any given project. Those could be a very simple question, like what % of the total EEZ area does this shape cover? Or it could be more complex, like this example here, which is showing what ecosystem services are provided in the overlapped area. It is important to note that while using this tool, like these analytical reports, once they're created, is very simple. But at the moment, customizing them does require some JavaScript knowledge. However, our lead developer is working on a fully no-code option. It'll be a graphical interface, and that should be available sometime next year. Okay, so the partner component to the analytical reports is the use of CSketch forums. And so users can post conservation plans that they've created along with the rationale for why they did so. And that populates a forum. And then other users can respond to that. They can copy the plan that was posted and edit it, and then post that in this sort of iterative process. And so it facilitates a collaborative planning process, and also, very importantly, it creates a preserved record of how a plan evolved over time. So you don't just get a final plan, you can look back and you can see how it developed. All right, now most importantly, let's talk about use cases. I'm going to talk about how CSketch was used in the context of Mission Atlantic in the South Brazilian Shelf, and some other ways that it's facilitated ocean protection. So the Mission Atlantic IEA case study in the South Brazilian Shelf used CSketch as the primary hub for visualizing, organizing, and sharing data. As an example, we can look at the Brazilian benthic habitats data set created by D'Souza et al. Earlier this year. I encourage you to go on to the C-Sketch Brazil project and explore that a little further. It's a really cool data set. Some more examples. This is a fishing effort along the Brazilian coast derived from Global Fishing Watch data. We have sea surface temperature anomaly from NOAA Coral Reef Watch, wind energy infrastructure, and we could spend all day going through all the data sets, but you get the idea. There's a lot of them, and they're easy to view, and it's a powerful thing. So essentially, C-Sketch offered a single shared repository for data sets like these that were originally from numerous disparate agencies and other sources. And Dr. Marinez Scherer, the lead author on this case study, explained that by compiling all the available data and being able to easily view it on a map in C-Sketch, it helped the people involved in the project see, one, what data was available and the nature of those data, but also what data were missing, which is perhaps even more important. And so seeing these data gaps actually spurred them to conduct or push to conduct an ocean use survey that would help them understand artisanal fishing and other ocean uses, particularly small-scale coastal ocean uses. And this effort is actually currently underway in the northern states of Brazil. And the goal is just to better understand where the ocean is most valued for artisanal fishing, aquaculture, tourism, research, and other use sectors. And essentially, this process entails teams of local facilitators going into coastal towns and villages to capture input from the people that directly rely on the ocean. And this includes even more remote areas that don't have internet access because C-Sketch surveys can be used offline. So essentially in the process, participants draw areas they value on a map for their use of the ocean. And this word value, this doesn't have to mean economic value. The interpretation of that term is up to the respondent. And once a representative sample of ocean use is captured, these responses will be aggregated into anonymous spatial heat maps. To better understand the products of an ocean use survey, we can look at a completed survey project a bit further north in the Atlantic. So in 2022, a similar survey of ocean use was conducted in the Azores. Nearly 2,500 responses were collected, and because some of these were group responses, this represented the ocean use of over 5,000 Azoreans. And to get an idea of what this data looks like pre and post aggregation, we can look at the following visualization. And so essentially this illustrates the amassing of shapes that survey respondents have drawn and how it aggregates to form the final heat map. And so this heat map is all ocean use sectors combined, just used for example's sake. But typically there would be a separate heat map for each use sector. So commercial fishing, recreational fishing, etc. But these heat maps can be used as input layers in prioritization models. They can also be used in C-Sketch surveys to see how potential plans would overlap with these areas of value. And they're also valuable as just simply visual aids during the planning process. C-Sketch was also used for stakeholder engagement in the offshore planning process in the Azores by allowing stakeholder groups to view, draw, and assess proposed plans, similar to what I discussed in California. And this helped the process along and helped stakeholders engage during the process. And as you all know, the end of that story is that 30% of the Azores EEZ was protected. And on that positive note, I'd like to quickly recap and conclude the presentation. C-Sketch is a totally free tool for MSP and much more. Its functionality has been molded by countless hours of on-the-ground use in marine projects around the world. It was an important part of the Mission Atlantic work in Brazil and catalyzed the ocean use survey there. It helped the Azores meet their 30 by 30 goals. And all of this begs the question, how might it help with your work? Thank you so much for your time.
Great. Thanks a lot, Peter. Quite amazing to see this tool developed, and also that it's actually taken up in real management decision making, and quite thrilling.
Absolutely.
Are there any comments around the room? If not, I may have. So I'm curious about the planning part of this tool. Will it allow to this kind of prioritization tasks? Let's say that you can say, okay, close off 30% of this area by minimizing trade-off with these and these sectors. Would it be able to do that prioritization as part of the tool as it currently stands?
So at the moment, most of the prioritization that's done, or almost all of it, is done outside of C-Sketch, Marksan or Prioritize R.
Yep.
But we are working on integrating some like trade-off modeling into the actual reports themselves.
Okay.
Yeah, so stay tuned.
Okay, so that might be a feature down the road, because I think that's really the most useful thing for. I mean, of course, it's great to be able to map layers and not draw polygons yourself and look at the outcomes, but maybe really use it for this sort of prioritization exercise would be interesting. So I'm glad to see that's in the pipeline. So.
Yeah, and it's a constantly evolving platform, and the more people that make projects and get in touch with us, the more functionality we can add.
Wonderful. Yes, is a question down here.
I was just wondering if there was also a quality control or validation process included, as it contains multiple data, to make sure that the data are consistent before you can use them.
So because each project is managed by whichever country or NGO created it, that's up to them. Data that we specifically work with, we have some QA, QC policies, but and when it comes to the ocean use survey heat maps, we do send those back to stakeholders for review before we use those, but it's kind of on a project-to-project basis.
Thanks a lot, Peter. Thanks a lot. Wonderful.
Thanks so much.
Good.